Hi, in the previous video we talked about first order filters, right? So let's say we have a filter here and I'm just going to draw it as a block diagram, and let's say it's a low pass filter and it's a first order filter. So what is the gain characteristic of this filter going to look like? The gain characteristic of this filter is going to look like this, right? And now what we'll do is, how do we get a higher order filter? To get a higher order filter, maybe what I can do is I can put another low pass filter here, okay, whose gain characteristic is exactly the same as this. Okay, so let me draw that there. Draw it here. So here's the gain characteristic, and well, my drawing is, it doesn't look exactly the similar, but let's say these two characteristics are exactly the same. Now, what is the overall characteristic going to be? So let's say this is V out and this is V in, okay? And let's say this is V1. We know that this is V1 over V in, and this is V out over V1, right? So what is the overall characteristic going to be? So let me plot the characteristic here and say what is V out over V in going to be. Now it's fairly straightforward, and I think you would have seen that all we need to do is we need to multiply this characteristic with this characteristic. Okay, so let's try and do that. So in this region where the gain is 1, the multiplication of this and this just gives us 1, right? So let's plot that. So we have a gain of 1 initially, and then what happens what happens in this region when you're going down? So you take any particular value. Let's say you take the value of 0.7, okay, somewhere here. At the same frequency, the value here also is 0.7. So basically, the value here is 0.7 squared, which is 0.49, which is much less than 0.7. Similarly, you take a value of, let's say, 0.4. So 0.4 squared is point, isn't it 16? Yeah, 0.16, right? So what you see is, if the original curve was going like this, because you are now squaring the terms, because you are multiplying these two um, gains, what you start to get is a gain which has a much higher slope. And in fact, if you take it in log terms, the slope is double, right? Because a squared becomes a log term in the log scale, uh, right? So you have, so if your slope here was minus 20 dB per decade, and similarly the slope here also was minus 20 dB per decade, in this case here the slope is going to be what? It's going to be double of that, and it's going to be minus 40 dB per decade. Okay, and that's one way in which you can make higher order filters. You can put one low pass filter and another low pass filter, and let's say you put a third one, then your gain becomes minus 60 dB per decade, and so on and so forth. So you can get higher and higher filters, such which cuts off the high frequencies much better than just a first order filter.